Hey y'all, how's it going? Hope you guys are hanging in there all right. Got another lesson coming your way. Today we're going to be talking all about analog inputs and outputs. And I'm kind of excited about it. Hopefully you guys are enjoying the stuff that we're doing with the Arduino stuff. I've been learning a lot. I've been thinking it's really cool, and hopefully you guys are kind of in the same boat. But give me feedback if there's things that you guys want to see, things that you guys want to change. If you're overwhelmed, let me know. Shoot me an email. I want to hear from you guys. I wanted to start off today by going over the kind of what we did in the last lesson, which was kind of wrapping up with the spaceship interface. Seems like you guys mostly did good with this and didn't have too many problems. A few things I wanted to kind of point out and mention that you guys should keep track of. Number one, try and keep your wires organized and as neat as possible. Not going to name any names, but Jack Ani, I turned in some work where the wires were just all over the place. You know, they're totally scattered. They're all green. I'm like, what is going on? It really makes it hard to follow. So one thing I like to do is I like to kind of color code them red and black. You know, for example, here's my power coming to this power positive strip, 5 volts. So I made that a red wire, right? Going to the ground, I made that a black. That's kind of standard. We're used to doing that. So try and keep your wires organized. If you need to change the color, you just click on them and you can change it to whatever you want it to be. Maybe I'll change it to pink. How cool is that? So that's one piece. The second piece is to make sure that you keep track of which pins go to which things, right? So for example, I had some people who kind of had the things going to the wrong pins, and that what happened in reality didn't match with what they had in their code, right? So make sure that you're keeping track of that and keeping track of what is what. Within the code itself, make sure that your syntax is correct, that you guys are kind of typing things in correctly. The programs are kind of particular about that. For example, if I delete that semicolon, right, it's going to give me this mad error message. But if I look at it, you know, I can kind of do some troubleshooting, and it says, oh, I need a semicolon there. I'll add in a semicolon, and then it should work out okay. Another thing with this is that you guys can feel free to fidget around with some of the code, right? Maybe change the delay times and things like that to kind of make it your own and customize it and play around with this, right? That's really the best way that you guys can learn. So in any case, this and what we've been talking about so far was all digital. Okay, it's only working with digital inputs. In this case, it's a digital input as our button, or digital outputs. And once again, digital kind of means that there is, like, it is on or off. It's 5 volts or it's 0 volts, right? It's one or the other. There's no kind of fluidity. So if we kind of go over, and I know we talked about this before, digital kind of looks like this. It's either 5 volts or it's 0 volts, right? So either for an input or an output, it's either going to be fully on or fully off. Okay. Now today, what we're going to be talking about and getting into is looking more at analog signals, which are smooth, right? And anytime we're talking about a signal, it's going to be, we're referring to a voltage, right? So a voltage that is either being sensed in the input or voltage that is being put out, right? Now, these Arduinos, they don't have a digital or an analog output, but they do have an analog input, right? So they can sense a continual range of voltages here, and they can output what's called here PWM, which we'll talk a little bit more about. But they can kind of simulate an analog output that's a little bit smoother, like that curve here. So that kind of approximates and gives us that same kind of range of variability. And we'll talk more about what that looks like as we get into it. So let's close out of that. And today, we're going to start messing around with our first kind of analog sensor. Right? We're going to talk about an analog sensor, and then we're going to talk about an analog output. And then we're going to kind of combine the two together. So for this first one, the analog sensor, what we're going to use is we're going to use a potentiometer. I'm just going to click and drag into here. Now, a potentiometer is also known as a variable resistor, right? So what it has here, if I go ahead and start the simulation, so I can just turn this, right? It just has this dial, right, that I can turn, right? It's got a dial I can turn. It's as simple as that. And it has 3 pins here, right? Now, so this pin, the outside pins go to positive. I'm going to make this one positive. Doesn't matter which one you do to which, but I'm going to make this one go into positive, and this one's going to go to the negative there, right? So those 2 pins connect to the positive and negative, and I'm running a current through this potentiometer. And then as I change the dial, what it does is this thing is called a wiper. And there's a little piece of metal in there that actually kind of shorts the resistance, right? So this here, I have it set at 250 kilo ohms. It doesn't really matter what you set it at, but that means that it can go from 250 kilo ohms of resistance to 0. And this guy right here, this wiper pin, right, is what I use to actually sense what the resistance is, right? Because as I turn this, right, a certain amount of voltage, right, is going to be sent down this pin here. And so I'm actually going to connect that pin here to my analog sensor at A0. So I'm going to set that up at A0. Okay, and actually, I don't like that. I'm going to delete that guy, and I'm going to go ahead and make it a little bit neater and do a little turn there. So that guy's going to go to A0. Okay, so now my wiper, the one that's actually sensing, which is always the wiper here, is going to my analog input. Okay, so this analog input is going to be sensing a range, a fluid continuous range of voltages, right, coming from this, right, as this wiper kind of diverts some of that voltage down to here. Now, I'm going to go ahead and I'm going to start up my code here that I have written in here for you guys. I'm going to go ahead and start the simulation. Now, one thing I want you guys to see is down here, we're going to be tinkering around with this, we have what's called a serial monitor. I want you guys to click on that. So click on the serial monitor, and you will see that as I change this dial, right, the serial monitor is going to give me a range of values going from 0 all the way up to 1023. That's the max. Now, a question here that you guys might be asking is, why does it go from 0 to 1023? Well, the reason for that has to do with binary, right, which is the way that these computers kind of read and communicate. So binary works in 2s. You guys can learn all more about that if you guys want. In free time, I don't have time for it in this video necessarily. What you need to know is that 10,020 or 1024 is 2 to the 10th power, right? So it's a binary number that you can count to. And the thing with binary is that if using just 2s, right, 10 positions of either 1 and 0, I can count all the way up to 1023. I can almost get to 1024, but then I can't quite add in another 1. So I can get to 1023. And so that's why this range of values goes from 0 to 1023. And that's essentially what this pin here can read, is a range of values that correspond to those voltages, right? Now, if we dive in a little bit to the code of how I did this, there's a few things that you need to do. Okay, number one, in our setup, we need to type in here this serial.begin, right? And we have 9600. Well, what does 9600 mean? Well, that's just referring to, it's going to read, just gonna put in a comment here. So this is reading 9600 bits per. So that's essentially how fast the serial monitor is actually reading what's going on in this analog pin. But the serial begin command is what tells you to start writing something on the serial monitor. It turns the serial monitor on. Okay, so that's what we do in the setup. So that just runs once, we turn this thing on. And then in the loop, what we're continuously doing is we've created a new variable, a new integer, right, a new number. And that number we named sensor value. And so we just named that sensor value. I could change that name to anything I want. But we're just going to leave it at sensor value for now. And that new number, sensor value, is going to be equal to whatever this pin is reading, right? Analog read of A0, right? So analog read means you're going to read what's happening here at pin A0, okay? And whatever that is reading, that number between 0 and 1023, is going to be set as my number for sensor value, okay? Then I have what's in here, this serial print command, right? It's going to print then here whatever my sensor value is. So whatever that number is going to print down here. And there's a little bit of a delay to kind of smooth it out. Right, so as I run this, right, this guy is continually, right, reading what this pin is getting, right, based on how I move this. It's using that number, and it's making that number this thing called sensor value, that variable. And that variable then is being printed here. Right, so that's how I can actually change this and then read it and see what's going on. Right. Now, there's some things that I can do with this that I think are useful to kind of point out, some manipulations that you can make. Number one is this is serial.print ln, right? Ln standing for line. Okay, so if I delete that ln, I just want you guys to see what happens. Whoa, right? It's just doing in one line. So in order to return on this serial screen, I have to have this, good, stop the simulation, I have to have this ln in there. Right? And if I do that, then it's going to print down in a nice line like that and makes it easier to see. Now, another thing that I can do is if I hit enter there, I can type in serial.print. And let's say that I want it to print something in front of that number, so I know what that number means. Let's say I just want it to say sensor value, right? Well, what I can do is in quotes, I will say sensor value, and what's in quotes just prints as text, right? Sensor value space equals space, end quote, right? So everything that I put there in between those quotes, it's just going to print as is, parentheses, semicolon. So it's going to print sensor value, and then right after that, sensor value equals space equals, and then sensor value space equals space, and then right after that, it's going to print the sensor value that I'm actually reading, and then it's going to, because I have the ln here, it's going to create a new line after that. So let's see what that ends up looking like. All right, so now we're getting sensor value is equal to 389. And as I change this, work with me here. As I change this, I see that the sensor value there is changing, but this is not actually changing because that's in the quote. It's staying the same. Whereas this is actually referencing that variable, which is changing as I change my potentiometer. Okay. So that's something that you guys can do there. This is useful to know because we've set up a variable, an analog kind of sensor, and we can actually see what it's getting. So we can see the values that we have. And that becomes useful if I wanted those values to kind of reference something. So just to kind of show you guys, I have these in quotes down here, but I'll go ahead and bring these on up. So this is some code that I wrote here. And what this does, and what I'm doing here is I'm actually, I'm doing the exact same thing, but what I've done is I've created another, another variable that's a floating variable, meaning it can be a decimal, right? Integers can't be decimals, but these floats can. I've called it voltage. So what I've done is I've mapped whatever this dial is at, right, to whatever voltage it's going to be. I did that using a mathematical operation. So I said this float, this voltage, right, is equal to my dial value, right, which is my sensor value from the potentiometer, divided by 1023. So if I have 1023 divided by 1023, meaning that this is full, then that's 1, and then I multiplied that times 5, which is my voltage coming out of here, right? So then I'd have 5 volts. So if I turn this all the way up to where the dial reading is at 1023, then that means that there's 5 volts coming to this pin here, right? So I can just do a simple mathematical calculation like this, right? Just math. So I create a new variable called voltage. Voltage is equal to whatever dial value I get divided by 1023 times 5, right? And I can map that on there. So if you guys want to try this, I'd kind of recommend it and check it out and see if you guys can get this set up to where you can actually see what voltage, right, you're getting coming into that wiper blade. And then we could use that voltage, right, to do something, right? It's kind of cool. So that is setting up a sensor, right, an analog sensor. That's what it takes, right? You just kind of set it up. You hook up the kind of middle pin there to one of your analog pins, and then you can actually read what's coming out, and you can print what's coming out using that serial print command on your serial monitor. Okay, so that's that first piece. Now let's say that I wanted to have a output, right, from this. So let's say instead of an analog input, let's say I wanted to have an analog output. So for example, if I want to kind of have a smooth range of values, a smooth range of voltages, I could use that to like take a light. And if you guys have ever seen this, you can have like a light switch where you can turn it and the light will get brighter, and you can turn it the other way and the light will get dimmer, right? Or you could have some kind of code where you could have a light kind of flash on and then flash off, flash on and then flash off. And in order to do that, we have to have what's called, it's kind of like an analog output, but it's called pulse width modulation, or PWM, pulse width modulation, right? So if I wanted to have something like an LED that's fading in and out, right? So let's say I have here set up an LED, right? And let's say I want this LED to turn kind of on and off and fade, right? Well, I can use these pulse width modulation pins as an output to do that, right? So these ones that have these little squigglies here, right? I can use those to do this kind of effect. I can't do the ones without the squigglies, they won't work, but the ones with the squigglies, I can use to kind of create this effect, right? So let's see what that ends up looking like. Pulse width modulation, a little bit more information about this. So when I'm doing this, essentially it's still a digital signal. It's still either on or off, right? This LED is going to be getting either 0 volts or 5 volts, right? But if it's getting 5 volts continuously, then it's on at full brightness. If it's getting 0 volts continuously, it's off. But if I turn it on and off at a regular interval, kind of faster than my eye can pick up, it'll appear to just be dimmer, because it'll be on and off, on and off, on and off. So my eye will pick that up as just being dim, right? So that would be like half duty cycle. It's on, off, like half the time. So I see that as like half lit, right? 75%, I see that as like 75% on. 25%, I see it as like a quarter on, right? And this is the idea, is by changing that, I can change, right, how bright it is. So what I can do here is I've set this up off of pin 9 just through my LED, got my resistor, and then to ground, right? And oh, and by the way, with all these, you don't actually need the breadboards. You can do it without the breadboard. I kind of like it because it's a lot of times when you do this in real life, you'll use a breadboard because it's pretty easy, but you can also do it without. But if I look at my code here, this is just the simple code I have set up. Okay, I've got this new this piece here that's just saying, hey, I'm creating a variable called LED, and LED is referring to pin 9. So anytime that you see LED, it's referring to pin 9. Okay, so in my setup, I've said the pin mode, right, of pin 9 LED is output. So pin 9 is going to be an output. I've named that pin LED. Okay, and then what I'm going to do is within this loop continuously. So in the loop, it's continuous. I'm going to write, analog write is the command. So I'm going to put that LED at, and I can pick a value here. Okay, so at pin 9, we're going to send out pin 9, and I can pick here anywhere a value between 0 and 255. Why 255, you might ask? Well, binary, right? 256 is 2 to the 8th power. So similarly, I can set up a range of outputs there anywhere between 0 and 255. 255 being essentially full power, 100% power. So that would be, if we look at our pulse width modulation, that'd be 100% duty cycle. So it's at 5 volts the whole time. 0 being on 0 time. What's half of 255? Like 125, right? Being half duty cycle. So if we kind of mess around with this, if I start the simulation right now, it's at 255, we'll see the LED is on full, right? If I turn it down to 125, right, then it's at like half. And if I put it on at 0, then well, it's off, right? But notice I can even put this at a really low number, let's say like 25, and it will turn on. It'll just be very, very dim, right? So that's the idea, is it's not quite like just, it's because once again, these LEDs, they need a certain voltage, right? So I couldn't really just like dim it. I couldn't put down to like 0 volts or like 1 volt, right? Then the LED wouldn't work. So what I do is I send it the full voltage it needs, right? But I kind of chop that up into bits like this, right? To make it seem a little bit fainter, a little fainter, okay? So that's the idea there. That's how we can use this analog write with this pulse width modulation, right, to get a value like that. Now let's say I want this to fade, right? Well, there would be a manual way to make it fade, right, which might look something like this. Let's say I want it to start at 0, and then we could do this just like we did kind of with the flashing, except for let's say I want to choose a few different values. So I'll write it at 0, and then I'll have a little delay, right, of let's say 1 second, 1,000 milliseconds. Okay, and then I'm just going to copy this, Control-C, and paste, Control-V, and copy that a couple of times. Okay, and let's say one of these times I want to add 125, and then one time I want to add 255, right, that maximum value that we can have. If I hit start simulation, then what we should see is I should start at 0, it should get a little brighter, up, and then back down, right? So it can kind of turn on and off, and I can vary that. And I could do this with like a loop like this. That'd be one way, right? Or we're going to go over another way, right? So let's say I want it to fade in and out smoothly, right? In and out smoothly. So I want it to get a little bit brighter smoothly, right? And I want to get it a little bit dimmer smoothly. And I want it to go back and forth. So it's like almost like breathing, like a breathing LED. Okay, well, if I want to do that, I want to take a second and consider, what would the flow chart for this look like? Okay, so this, especially when you're encountering a new project, this is a good way to think about this, right? How could we actually go about this as a computer? What would that flow chart look like? Okay, so at the start, right, I might want to turn the LED on at minimum. Okay, so that's kind of smallest value. And then I'm going to ask a question, right? I'm going to say, hey, because I want to start like turning it up, right? And so, but first I want to ask, hey, is it at its max, right? And if it's not, what I'm going to do is I'm going to add a little bit to the LED output. Okay, I'm going to add in a little. I'm going to up that kind of PWM a little bit. PWM. And then I'm going to just wait a second, and I'm going to say, hey, is it at its max? If not, I'm going to add a little bit more. Is that its max? I'm going to add a little bit more, so on and so forth, until it reaches its max. When it reaches its max, right, then what I'm going to do is I'm going to start cutting away. I'm going to start subtracting a little. And as I subtract, I'm going to say, hey, is it at its minimum yet? No, I'm going to wait. Is it at its minimum yet? No, I'm going to subtract a little bit more until it finally reaches its minimum, and then I'm going to start adding. So what I have here is this kind of two-sided loop, right? Where in one situation, where it's below that max, we're going to keep adding a little bit until we get there. And then once it reaches the max, we're going to start taking away a little bit until it gets down to its minimum, okay? Now, one thing I put here is if we think of the inputs that we need in this case, right? Are there any input sensors? No, no input sensors, but there is one output, and there's our LED. And if we think of the variables that we need, right? The things that we might want to consider in this, we need the LED value, right? That's something that we're going to be putting out. Is the LED value at its max, right? And we need to think of what a little bit is. Subtract a little or add a little, right? What's that going to be? Okay, so always thinking about this kind of flow charting as a way to kind of talk about this. Oh, and by the way, for the pulse width modulation, kind of what we're looking for with this breathing is we want like a little pulse, and then a bigger pulse, and then a bigger pulse, and a littler, right? So it can kind of go back and forth there. Or even better, right? Like this part, it's getting brighter and brighter and brighter and brighter, and then it's getting fading, and then go back and get brighter and brighter and brighter, fade, right? So that's what we're looking at there. Let's go ahead and close those out. Okay, so here's what we have so far. Now, how can we actually get this to run? Well, fortunately for you guys, I've gone ahead and I've done this. So I'm going to go ahead and kind of bring that on up here, right? Boom, boom. And this is what we end up having, and this is what it looks like, right? Ooh, breathing. Okay, so looking into this, what did I do here? Okay, and once again, it's like I would love for you guys to copy this down and write it down and see if you guys can do it. So what I did is once again, I have my LED as pin 9. Okay, that's my output, and the pin mode LED, right? Pin 9 is going to be an output. Now, I should say, right, I could totally cut this and scrap this and put in just 9 here. Put in 9. Everywhere where there's LED, I could just put in 9. Okay, but I'm not going to. All right, so I've said that pin 9 is, we're calling LED, right? Pin mode pin 9 LED, we're going to put as an output, and that's going to be the setup. Now, I have some other variables up here, which I kind of mentioned over here, right? I need a variable to say, hey, what is the LED variable, the LED value? Right, somewhere between 0 and 255. And then what is a little bit? How much am I going to change when I add or subtract by? Okay, so I've added in a couple of variables here. One is the brightness. Okay, now the brightness is that LED, right? Brightness, right? Between 0 and 255, right? And then the fade amount is that amount, the little bit that I'm going to add a little bit, or I'm going to take a little bit away from that brightness. Okay. So within the loop, here's what I end up doing, right? I'm going to write, so I'm going to tell this pin, number 9, and it's going to be an analog write, which means I'm using that PWM, the pulse width modulation, so I can use a value instead of just high and low, which we did with the digital write. I can actually set a value between 0 and 225, okay? So I'm going to do an analog write on pin 9, which I've named LED, right? And I'm going to set that value of that pin to whatever my brightness is. Right, so instead of just manually saying, hey, brightness 255, I've created a new variable called brightness up here. Okay, now brightness is going to start at 0 when I set it up, but then I'm going to say, hey, brightness is going to be equal to the previous brightness plus this fade amount, however much I want to increase or decrease it by. And that fade amount is going to be 5, right? Nice kind of round number, goes into 255 well, right? So I'm going to choose 5 as my fade amount. Now, if, so essentially what's going to happen here is it's going to turn on, it's going to start to go through this, right? The LED is going to turn on starting at 0. And then, right, the first step is it's going to take brightness, and it's going to add it, which is 0. So 0 equals 0 plus my fade amount, which is 5. So 0 equals 0 plus 5. So now brightness is 5, right? Because I've added on 5, which means that my LED will start to turn on, okay? Now, if I just had this part, right? What would happen is that it would continue to add 5 until it reached max brightness. And then once my brightness value got above 255, it would start back over, right? So actually, what I can do is I can put this in comments here. Let's just do this on these lines, // slash, right? And if I start the simulation, it doesn't like that. It doesn't like, oh, because I have that if there. Oops, so I need a backslash there. Okay, now we can start the simulation, right? And so what it's going to do is it's going to turn on, and then it's going to go back down. And so it's going to go up and then back down, up and then back down. Okay, which is not necessarily what I want, right? I want it to kind of bounce back and forth. The reason why this is happening is because this brightness value is getting up above 255. So I'm going to go ahead and stop that. I'm going to bring back this in here. I'm going to explain what this does, right? So what I did here is I said something kind of clever, right? Because here we're just continually adding 5 to our brightness, right, in rapid fire, right? But here I'm going to say, hey, if the brightness, and we'll just pay attention to this part first, if the brightness ever, if that number ever is greater than or equal to 255, right? So if it's ever greater than 255, what I'm going to do is I'm going to say, hey, this integer, this variable fade amount, that's going to be equal to negative fade amount. So instead of 5, it's going to be negative 5. Well, then when I take my brightness, which let's say it's at 255, now my fade amount, instead of being positive 5, it's negative 5. So I have 255 minus 5. So it starts to go down, right? Which is all going to be great until it reaches 0, in which case it's going to keep adding negative. Well, that's where I have this other part, right? If the brightness is ever less than or equal to 0, then fade amount is negative fade amount. Well, if fade amount is negative 5, and then negative 5 equals negative 5, now the fade amount is positive 5, and we start to go back up, right? And that's the idea here. Now, these little lines in here, right, what those mean is those mean or. So if brightness, and by the way, you can get those on your keyboard. They should be right above the Enter key, right? You can get those right there. But if the brightness is less than or equal to 0, or the brightness is ever greater than or equal to 255, okay, then we change this around. And this allows us to go up, down, and up, and down, and up, and down, and up, and down, and we can fade it in and out, right? Now there would be a couple of ways in which we could adjust the speed of this fading, right? One would be to change the fade amount. Let's say I make this 10 instead of 5, and I start the simulation. Right now it's going to fade even faster, right? So that would be one way to do it, maybe the most logical way in this case. The other way would be to change the delay here, right? That little bit of time that we wait before adding or subtracting 10, right? But I kind of like this way because we've already programmed that in. Okay, so this here is doing exactly what we coded for here, what we asked for in our flowchart. Okay, in this case, we're just kind of doing it as coding. Okay, talking to our computer. So this is how, just using kind of this coding and using this PWM pin, this analog write, right, putting in that range between 0 and 255, I can turn this LED on and off and make it kind of breathe like this, which is really cool. Okay. So make sure you guys try this out. You guys are free to kind of mess around with this and see what happens. And then the last piece that you guys have to do is this, right? So what I did in this case, and I'll kind of walk you guys through this one, but what I did is I tied these two together, okay? So instead of having the LED just kind of breathe on its own, I wanted to say, hey, can I add in a sensor so that this machine can sense its environment, sense something that's happening, and then respond as I see fit, right? So what I wanted to do in this case is I wanted to tie the position of the potentiometer to the brightness of the LED. So I wanted to create a dimming, right, bulb that I could control. So thinking once again, what will the flowchart look like for this, right? It's actually even simpler. What I need is I need to start. I need to read the value from my sensor, from the potentiometer. Okay, I need to convert that value into a value for the LED. Okay, so the potentiometer value goes from 0 to 123, or 1023. The LED goes from 0 to 255, right? The LED output. So I need to convert the value from the potentiometer to a value that can be used for the LED, right? And then I need to turn on the LED at that value. I want to print that value so I can see where it's at, and then I'm going to do it all over again. So I'm going to continuously loop through that. Okay, now our inputs are the potentiometer, the output's the LED. The variables, I need that LED value, and I need the potentiometer value. Okay, so how did I actually end up setting that over here? You guys are free to kind of pause this here and set this up and type it in. what I did is I really just combined these two circuits. I still have this coming out of pin 9. I still have this coming out of all the same stuff going to pin 0 here. Okay. But what I did is I created a constant, right? Constant integer, which I call dial, which refers to pin A0. So anytime that I have dial in here, okay, I'm referring to pin A0. Right? I could also type in pin A0 here, right? And it would still be totally fine, but I've kind of named it dial to keep track of it. Same with this LED pin. And I've created two changing variables that can change to integers. One is the dial value, the value of the potentiometer from 0 to 1023. And one is the LED level, right, from 0 to 255. I went ahead and hit my serial begin here, right? So I'm starting this serial monitor. And then in my loop, and the stuff that's kind of constantly searching, which once again here, that's this loop here, right? What I did is the first things first is I just set this dial value equal to whatever pin A0 is reading, right? So the dial value is going to be equal to the analog read of my dial, okay, of the potentiometer. So that means that dial value is now going to be equal to some range between 0 and 1023. Okay, now I'm going to convert that into a corresponding LED value. Okay, so I want my LED level, which is going to be the level of the LED, from 0 to 255. All right, well, I want that to equal, and now I'm going to use this map function. Now, this is a new function, and what's kind of cool, it only works with like integers, so you can't really use decimals in there. But what it does is I can essentially take, let's say I can scale things. So let's say I had a range of values from 1 to 100, okay? And I wanted to scale that down to values that were 1 to 10. So if I had 68, right, then that would scale down to be 6.8, right, which would round up to 7 actually in that case. And that's what this map function is doing. So LED level, right, is going to be equal to the map, going to map the dial value, right, which I just read, that's the from 0 to 1023, right? And I'm going to map that to my LED level. So the way we set this up, the syntax, is we type in map here, open parentheses, dial value, which is the input kind of value range, and that goes from 0 to 1023. And then I have these other two, right, are the output range, and that's 0 to 255. So now essentially on our scale here, 0 is still going to be equal to 0, and 1023 is now going to be equal to 255. So all of these dial values are going to be scaled down, right, to values that actually work as an LED level, right, for that pulse width modulation coming out of pin 9 there. And then I'm going to analog write, so I'm going to tell pin 9 is going to output pin 9 at that LED level that I've just calculated. Okay. So if I leave the serial monitor down, I just turn this on so you guys can kind of look at it and see the simulation. Right now it's at full strength. Right, I turn this down, and we see the LED ends up going off. Ooh. Turn it on, and fade, and max brightness, right? So if we zoom in, maybe we can see a little bit better. Right, so fading, 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 right? And this is something where, unfortunately, like with the computer, it's not quite the same level. If you had this like in real life, and you can only imagine like how cool this would really be to be able to see these different values. It's still pretty cool in here, I think. But that's how we can do this, right? Now, the last piece that I have on here is I wanted to print those results to my serial monitor, right? So what I have here is once again, I already begun my serial monitor up there in the setup, right? And now I'm going to print, right? And I'll pull this up now so you can kind of see what it looks like. Serial print in quotes, right? So it's just going to print that sensor space equals space, and then my dial value, so that number. And then I have serial print parentheses tab. I put in a tab so it leaves a space in between here. LED space equals space, right? And then I'm going to have the LED level. Now notice after this last one, right, all three of these, this, that, tab, now are all in a line, right, all in a row, and then to have it on a new line, I have to have after this last one, this ln, serial.print ln. And that's going to print that LED level, okay? And so then it's going to run through, and now if I start it here kind of like this, I see, right, it's going to read the sensor value, right, it's going to read the corresponding output value for the LED, right? And I can see the LED fade as such. Right? And that's that. So boom, just like that. You guys went ahead and created a LED that you can kind of control, that you can fade, you can brighten, you can dim. So we've taken an analog sensor, right, and given it an analog output, right? So we now have a kind of more nuanced sensor of the environment, and then now we can create a kind of more nuanced response as well, right? Which is kind of cool. Now, this is going to be very important because we're going to get into many more sensors. Some of which are going to be digital, but others which are going to be analog, right? So we can use an analog like temperature sensor, which is what we'll be using in next class. Ultrasonic rangefinders, things like that, right? So that we can measure like distance, measure temperature, measure all sorts of things, and then code responses, okay, to what's actually happening there. So here's your guys' homework. Hopefully you guys followed along and went through all these steps, and I'm expecting that you guys did that. And hopefully you've all at least reached this point. And then what I'd like you guys to do, and this is your homework, is I want you to take it a step further. Okay, and I've got this up on Classroom. But see if you can do something cool using a potentiometer and your LEDs, right? Can you control two LEDs, right, with your potentiometer? Can you maybe make one get brighter while the other gets dimmer, right? Could you put them on two separate potentiometers? So you could have a couple of different dials. Could you do like 3 of them, right? Let's see, could you, I don't know, any other kind of things that you guys can think of. I want you guys to get creative with this and see what you guys can come up with. Take a picture of the full screen or a screenshot of the full screen. When you're done, I need to be able to see all your code. I need to be able to see the build. And maybe even better would be to take a short video, record that, upload that to Google Drive, and share it with me. But that's what's coming your guys' way. And I hope you guys have fun with this. Hope you guys learned a lot and are hanging in there, doing well. Give me feedback if it's too much, too little. You want to see something else. But see you guys later. Peace out.